Hello everybody and welcome back. So in this next lesson we're going to be talking about strings and how to manipulate them and kind of grab little sections of it or alter them in any way we need for our VEX code, right? Now we have been using strings up till now, in certain ways. Most commonly you'll come across strings when creating something like a name attribute. Often with your rigid bodies or fracturing, you need some kind of name attribute whenever you're packing. So this is quite common to have to create a very specific name. Sometimes we'll also use them to create very specific types of IDs. So you'll find that your normal IDs are just integers, but sometimes that won't actually do when you're wanting to maybe take a primitive integer, so basically a primitive ID, and combine it with a point ID as you pass that information down. So then in order to do that, we've already done an example like that in this VEX course where we concatenated two different string IDs to make a much longer sort of serial ID. So that is something that we use quite often. And also sometimes you're going to want to manipulate file paths, things like your shop material path or the path to an actual piece of geometry where you're wanting to rop something out or read in a texture, just manipulating file paths. So these are some of the most common uses of actual strings, and we're going to want to be able to manipulate these strings in different ways to get what we want. So the first thing to understand about strings is that they are basically arrays. Okay, we have already sort of mentioned this, touched on it a little bit, but strings are basically arrays. And now that you know how to work with arrays, you should at least have a little bit more familiarity. If you think of a string, so a sentence, something, this word here, underscore something, it's literally just an array of characters. So the first index in this array is an underscore, the second index is an S, third index is an O, and so on. And because of that, we can access these strings in the same way that we can with arrays. So they share a lot of similar functions, and you can also just work with them in that same sort of way. So I'm just going to show you here. I've got a grid, just a basic grid, so that I've got some geometry, and I've created a string attribute called tests, with the value test string, and I'm looping over detail. So on detail level, I just have foo as test string, okay? Just so that I've got something to work with, and in a separate wrangle, also running over detail, I'm just going to manipulate this or kind of create other strings, and we're just going to show you how to manipulate the strings. So if I just enter here something like s at test, okay, and we just access our foo, but exactly the same as with an array, we can access a particular index. So I can say 3, and obviously my semicolon. Oh yes, and sorry, you will need to specify that it is a string, so you have to specify s at. It's one of those times where typecasting is very, very important. If we just say at foo, it's going to assume that this is a float, and it has no idea how to work with it like this. Okay, as long as you give it that s, then you're going to be able to work with it in the same way that you would with an array. So you'll see here 0, 1, 2, 3 is the character t, right? And that's what it's returned here. And in the same way, we can also slice. So remember, we were able to say, let's say, with a colon, but before is the character to start with, and then after is how many characters, the character to end with. So let's say we go maybe a little bit more. So from the third character to the 8th one, it's going to grab the T, the underscore, and then the STR from that, okay? Or we can leave out one of these numbers, so then it'll grab from the beginning to the 8th character, or from 3 till the end. All right, so that's just normal slicing as we would with an array, but we can do it with strings as well. Okay. Also, a couple of common expressions that are common between arrays and strings is just your append, which I'll show you an example of that just now, but you can append to strings the same way you would with an array. You can also check the length of the array. So if we just do, I mean, here we're accessing our foo, but we just say len, except obviously we wouldn't want our test to be a string, we'd want it to be an integer. And you'll see there it's saying that it's exactly 11 characters long. So you can check the length of a string array essentially. You can insert at certain points, so we could kind of take maybe at this after the T, we want to insert another character before we continue with underscore, then you'd be able to insert. So insert is one of them. Reorder and reverse as well can all be used. Okay, so that's just sort of what we have in common coming from working with arrays. But I want to also walk you through some of the expressions that are specifically designed to work with strings, because we haven't gone through these yet, and we will need to use these later on. So we're first going to go through a few of these, which are they all return an integer, because basically it's checking whether something is true or where within the string it finds this. So I'm going to pop up the help file here just to have, so you should be able to see the code on the right, the help file, and I'll walk through these in the middle so that you'll be able to read what it actually does, and also so that you can remember the name. And then on the left here you can see what attributes we're creating. So you should be able to kind of work this way. So we're going to use this ends with function. Now ends with is just essentially querying whether the particular string that we feed it ends with whatever we give it. Okay, so if I put a G, because it does end with a G, it's going to return 1. Or if I put an H, then it'll be 0, because it does not end with an H. But obviously it doesn't have to be a single character. It can be, ring, because it ends in string, so it's got those letters at the end. Okay, so it's essentially just, it's like having a star and then something like that, like with your normal Houdini kind of wildcards. So this is checking specifically if it ends in something. Often you'll use this with a file path, because you can check if it ends in .bgo.sc or ends in .rat for your texture files or something like that. So ends with, and we also have starts with, right? So that's self-explanatory. It's exactly the same thing. It does start with the word test, so this will return true. Then we have find. So find is going to be returning an index, which is going to be telling us where within the string we're actually finding what we're looking for. So if I give it str, it's going to return the 5. So this is not just a Boolean. It's not saying 0 or 1, true or false, yes, I do end or start with this, or no. Instead, this is telling us where within the string it is finding the characters str. So it'll say it's at the 5th character, 0, 1, 2, 3, 4, 5. It's where it begins. Okay, and if we have something, so that's why I had this O in here, where it will not find stro, then it will return a negative, and it will be, so here it's -12 because we checked the length of this is 11 characters, and so -12, it gives us a lot of information. It allows us to use this as an index when referencing to basically cause an error to occur, or we can check whether there's a negative or a positive to see whether it succeeded or failed. So it's giving us a lot of information, right? So, and obviously, if it's true, it's telling us exactly where that character starts. So that is pretty useful. And then our last one in this kind of category is match, which is similar to the starts with and ends with, where it's a Boolean. It's sort of saying whether it has found the match or not, except that this is using the standard Houdini wildcards. So you'll see here under match, you can use your question mark and star. You can use your except, so by using the caret function. So there's a lot of examples in the help file as well, and you'll see over here I've got the word test star, and it's saying yes, I'm finding test star, because star is including everything after the word test. You don't need the star in the beginning because there's nothing before it. But let's say we had the word well, the underscore, for example, it's going to return false because it's not going to find just an underscore. We would have to put stars in the beginning and the end to say, oh, are you finding an underscore which is preceded by some characters and preceded by some others. And in here you can also do a space separated list, and you can also you can do the exceptions. So you can say, well, look for an underscore, but only if you don't find the word test. And in this case it'll return false because yes, it has the underscore, but it has found the word test, so it'll return false. Okay. So very powerful ways of just sort of checking what we have to work with the string, right? Because if we want to make strings procedural, we have to be able to check them or search within them to find the bits of information that we're needing. Okay, especially when we're working with something like file paths, which have a lot of information. Okay. Now we're going to talk about joining strings. So here we have the concatenate function, which is the correct way of adding strings together. You can, if you want to, you could say s at new equals, and then you can do s at foo plus something, and it will return the same result. Okay, you'll see there it returns the exact same result. I can disable this. But it becomes more efficient when you have more strings. If you're concatenating a whole collection of strings, then just this concatenate function becomes a lot more efficient. Okay, and it is better practice as well. It's much easier from this to see what this is doing. Okay, plus you won't fall into the habit of trying to add, because yes, you can add strings, but you can't subtract strings, you can't multiply them, you can't divide them. So you don't really want to fall into the habit of concatenating this way. Much better practice to use the actual concatenate function. Okay, and that is true if you're doing Python as well. If any of you are into your coding, I see a lot of people concatenating strings with a simple plus, and you really should not be doing that. So please don't get into the bad habit of doing it now. Okay, right. So we can concatenate two strings, which is just to essentially join the two strings, and you'll see that it adds them in order. So if I had the foo afterwards, then it would be underscore something and then the words test string. Right, so it concatenates it in order, and you'll see append is doing the same thing. And this is, as I said, you can append to strings as though they are arrays, because they are. But you'll see it functions a little bit different. Append is a void function. It does not return anything, and it writes to the array that you feed it. So if you definitely want to just append into this string that already exists and you want to overwrite the attribute, then you're welcome to use append this way. But if you wanted to, like here where I'm creating the new string, then this would be the way to do it. Okay, you cannot just create, here you don't just say s at new equals with append, because then it will error. It will tell you, okay, no, I can't do this because I'm not actually returning anything. Okay, so you can choose between these two different methods depending on what result you're wanting. Okay, now I want to show you another way of joining strings, and that's with a function actually literally called join. But join, what it does is it takes an array of strings. Now, I hope you're following here. Although a string can be considered an array, it is similar to or acts like an array of characters. But you can still have a string array, which is an array of individual strings. So it's almost like having an array of arrays. Okay, so each of these individual strings is a word on its own. The array is 4 elements in length. Okay, but then this particular element has 1, 2, 3, 4 characters of its own. Okay, this one has 2, this one has 1. So just make sure you understand that when it's saying here that it wants a string array, that's not meaning just a string. It means an actual array of strings. So that's why I've created a string array here with these 4 words. And then I'm doing s at new equals, so I'm just going to set a new function, and then I feed it my array and then a joiner character. So with an underscore, it's going to join it with underscores. I can also leave a space, and then it will just be space separated, or I could put another character and then it would combine it like that. Okay, so you're able to just do whatever you need to in order to join a whole bunch of characters. And often this will be used when wanting to create a path of some kind. So maybe you're procedurally figuring out the location of the path one file or folder at a time. Then you'd be able to join it with a slash and actually create a file path. Okay, so that's a common use for that. And then sorry, I'm going to leave these active because I want to show you the exact opposite function, which is split. So split will take an array that already exists, the one that we feed it, and we tell it what the separator function is, and it's going to go and create an array where it's splitting that into separate elements based around this the separator character. Now you'll see in this case it's created an array that is exactly 1 in length, which is the entire thing, because it's not finding any underscores, because I've changed this to a slash. But if I change this back to an underscore, you'll see that it has created an array that is 4 in length. Exactly, this is a test for separate strings in an array. Okay, so it's essentially the exact opposite of the join function. Okay, then here I'm going to create a path because I want to show you the split path function. So split path is, it's acting similar to how this split is working, except it's only looking for essentially the last slash in the path, because what it's trying to do is separate the folder from the actual name, so the directory from the name of the file, right? So here I've created a reference to a string, and I'm pointing to a file on disk over here. So just in a folder on my laptop, then it says mytest.bgo.sc. Okay, so we're just pointing to a piece of geometry and wanting to find out where that directory is versus the actual file name, which can be sometimes useful to split those two. So that's why we have this split path function, and it is void, so it's not going to return anything. What it's going to do is it's going to write to a string variable and a name variable. So we can give those variables whatever names we want. I have called this dir and file because that made more sense to me than name, right? So I'm feeding it the path that it needs to split, and then 2 string variables where it can override and store the information coming out of here, right? And when I do that, okay, obviously we can't see anything because it's storing it into variables, but if I just deactivate these, this will be showing you how it has split the directory and then the actual file name. Okay, so that can be super useful, especially with something like texture files or shop material paths and stuff as well, where you want to maybe reference the same shop path, but then you want to change the actual shader name, then you can do it this way as well. Okay, so let's just disable all of this, and then we've got an L strip and R strip, which are just basically stripping leading white space from a string. This is stripping it from the left hand side, this is stripping it from the right hand. So this is the sorry, let me just pull it up over here. Well, I've only got L strip open, but anyway, this is the leading white space, and then this is the trailing white space afterwards. Now it's going to assume, if you feed it no second argument, that the white space is just actual space. But if it is something else, maybe underscores or something, then you can just feed it a string with the character that it should be stripping, and then it will strip those instead. But in this case, obviously that returns something false because it's not going to strip this away when we feed it this. If we give it no arguments, it will strip away the leading white space. And same with our R strip, it's going to strip any trailing white space after this the word. Okay, so there we are. And then here we have a little bit of work with digits, right? So we're talking about numbers that are within a string. And now you need to be careful here that, because, you know, a number, for example here, this 54, but if it is within quotes, so if it is cast as a string type, it acts like a string. Just because the characters happen to be a 5 and a 4, they do not function like an integer. So 54 plus 2 is not 56, but it's 542, because you're adding, in other words, concatenating a 54 and a 2 string, and it just adds them together one after another, right? So here we have a function which is checking whether something is a digit, okay? So in this case, it's going to return 0 because not the entire thing is not a digit. So if you're wanting to assess whether something is a digit, right, the whole thing needs to be digits. It's not just going to find digits at the end or digits within the text. Okay, so this 54 over here will return true. So you'll want to maybe check if you're ever wanting to convert something from a string into integer. Then you'd maybe want to run a check and say if it is a digit, then you can strip it out using the a to I, which I'll show you just now. So this will help you avoid, you know, any errors with actual having characters in that are not digits. Okay, so you can see there the difference between our 0 and 1. And then there is the opdigits function, which we have spoken about before when we did our wedging example. And what this is going to do is take the digits that it finds at the end. Okay, so this will be able to work with other characters, but as long as those characters are not at the end. If we have other characters that maybe separate these, so it'll read from the end. So here I've actually got some other characters in from the end. It will ignore these, it'll find the last set of digits, but if these are separated by something like, let's say, a dot, then it's only going to return the 4 because it's finding from the end the last digit. This is not a digit, so this counts almost like as a wall between the 4 and the 5, so it's just going to grab the 4. Okay, so you've got to be very careful how you use this function. But most of the time, if you're using it just to grab the digits from the end of an op name, like here, the 1 and the 2, or maybe frame number from the end of a geometry cache or something, then opdigits is quite useful. But it's always worth using things like these opdigits or maybe ends with or something like that to check before you just rely on opdigits for grabbing the last digits from a string, because you never know what it's going to do. Try and think of what variables there are, what your user may input that may be not what you expect. Okay, so that's always a pretty good rule of thumb in coding, is to try and account for all of the silly things that the user may or may not do. Because if they haven't designed the program or written the actual script, they don't know what they're supposed to be doing. Okay. So there we have that, and then we also have these two conversions, which is A to I, right? So that's going from you can remember it as like ASCII or alpha to I, to integer. Okay, so it's converting from string to integer, right? So it's the string 54 which will convert to a number, right? So num is now equal to 54, but this will be an actual digit. Okay, so if I had to say plus 2, you'll see it'll come out as 56. It has converted it to an actual integer and will therefore function like an integer. And then the s at new, which is over here, is 54. Now I'm feeding it an integer, but I'm converting it to a string. So if I had to try and plus 2 over here, it's going to error because I'm not feeding it two things that can interact. I'm feeding it a string and an integer. And if I do convert this to a string, then it will be 542, so 542. See, it will just function as a string array instead of actually adding the 2. Obviously, we could get around this by adding the 2 inside of the brackets over here, and then we'd get 56 as well. But again, this would be a string type. So even if I look at new is a string, and then num is an integer, right? And that's how we convert between these two. But again, you're going to want to maybe check whether it is a digit first, like this, before actually converting it. Okay, so these are some of the most useful functions that we're going to be using with strings to manipulate them and work with them, which you will do surprisingly often because, like I say, you've got your shop material paths. Sometimes you want to reroute those to, keep the same shader name, but actually point to an alternate, like shader network or something like that. If it maybe has, you've cached out all of your geometry with a shop material path embedded in it, and then the name of the shader has changed, or the name of the shader network has changed, or the path has changed, then you can reroute it. So very, very useful for all of that. Also for, like I said, creating names and IDs, things like that. Now, it's just important to note that strings have just a few limitations. We've mentioned things like adding them. If you add them, it's going to maybe not produce the result quite what you expect. Also, you cannot subtract strings. They cannot just be, you can't just subtract the word string from test string. You actually have to split it up and then drop the word string, or use a slice and grab the beginning few characters or something like that. So to maybe drop the word string from here, you could use the find function to find out where the word string starts, and then use a slice and slice this array from that point backwards. So you have to work with strings a little bit differently. And then one of the other things to note about strings, it's a little bit of a limitation, is that they cannot be interpolated. So if you have a string attribute per point, and if you, let's say we took an integer, so you had 4 points and a square, okay, and you're wanting to, in fact, let me show you. Let's talk about it with actual visuals. So if these 4 points here had different values, this was 0, 1, 2, and 3 maybe, okay? And then I wanted to read, maybe scatter a point on the surface, like over here near this edge. Then because of its location in UVs, when it tries to pick up the attribute, our float attribute, it's going to kind of interpolate between this 0 and this 1 over here, so it'll be somewhere between 0 and 1, but also it's not right on the edge, so it will interpolate a little bit of the 2 and 3 value, and it'll figure out what its value should be, okay? But you cannot do that with strings, right? They cannot be interpolated. So if this has a string attribute of A, like this, so the character A, and this has B and C and D, when you scatter a point on here, it will not know how to interpolate those values, so it will just come up as an empty string, okay? Likewise, not just about interpolating across geometry, but interpolating across time. You can figure out, you can trail points because their point position can be interpolated. It moves from this location to this location in a single frame, so then halfway, the subframe, it would be exactly halfway. So that's a linear interpolation. You cannot do the same thing with string attributes, right? You can't figure out if a string was A on one frame and B on the next frame. It doesn't know what it should be halfway in between those two frames, okay? So just keep this in mind. Sometimes when you have strings, you won't quite get the result that you're looking for. So, but as long as you know how they work, then you might be able to sort of avoid some of these limitations. Okay, so I hope that's made a lot of sense to you guys. And in the next lesson, we're going to be talking about regular expressions, which is another way of working with strings to manipulate them. But it's an extremely powerful tool which can be accessed in Vex, but it is not exclusive to Vex. It's something that is used across the in the board with a lot of coding languages. Python uses it. I mean, just a lot of languages use it. And the fact that Vex includes it allows us to do some incredible things with strings. Okay, so I hope you guys enjoyed that lesson, and I'll see you in the next one.